Hi, and welcome to MSc. In this video, we're going to be trying to answer the question of what is a function. To answer what a function is, we have to first start and look at what a relation is. So a relation is a mathematical relationship between two or more sets of values. And you've already seen these in many forms. You might have seen it through what was called like an input-output machine and through a variety of equations, right? So in these types of situations, there would be some type of input value, which would often be an x value, although it doesn't have to always be the variable x, and that would be put into this equation or machine. It would follow some type of rule, and it would output your other or resulting value. And that would typically be, by default, a y value. And you might have seen this through equations in a variety of different forms. But what you put in, follow a rule, and then you get that out. The input here is then your independent variable, and then you get out your dependent variable, because it depends on what you put in. And so you've seen this before, this style of equation and process. So let's look at the various forms, some of which will be familiar to you. So relations, mathematical relations, can take all sorts of forms. It can be in a table of values, which I'm sure you're quite used to, right? When x is -4, y is -1. So when -2 is input, the output is 1. There's also these mapping diagrams. Mapping diagrams are perhaps new to you. They are in a way a little bit like a mixed up table of values. And the mapping diagram uses arrows to say, okay, when I put a -2 in, then this relationship maps that value or changes it by following the rule that's established to -5. And we can see how this process works here. Ordered pairs are coordinates, right? And we could even turn this into a set of ordered pairs if we put set brackets around it, and that would make it a set of ordered pairs. And of course, in these ordered pairs, we typically talk about it being x, comma, y, because x is first in the alphabet. And so we know that when the input of 1 is put into the system, then 8 is your output. We can also see this through a variety of equations, some of which might look familiar, some of which might not, and then their respective graphs that get produced. So some of these equations look like ones you've seen, probably a line. You probably have seen the equation of a line before, y equals mx plus b, right? It's just the equation of a line, and that's a mathematical relation. As is the equation for a circle. You might have not seen that one before, although you might have seen it in some different problems or examples. And even some different sequences. This is Fibonacci's sequence, for example. It's the Fibonacci sequence. And it's a recursive formula here that says each next term is the sum of the previous two terms. And they've identified the first two terms as both 1. So it's a pretty famous sequence. All of these are relations, mathematical relations. Now, it turns out some of these are also functions. So let's look at how we define a function then. So a function is a very special type of relation in which every input of x has exactly one output. Okay, it can never have two outputs. If it does, then it's not a function. It's just a relation. So a function is really a special subset of relations. So again, I've listed some here. These are all functions that I've listed here for us to look at. We have a table of values, very similar to the table of values before, right? When I put in -4 as my input, I'm only ever going to get -2 out of this function. Same with the mapping diagram. I can only ever have one output for each input. And so on a mapping diagram, I could not have another arrow come over to the -7, not because it's going to the -7, but because that would be two arrows coming off that -2. I can't have that and it be a function. So on mapping diagrams, I can only ever have one arrow leaving my domain, my x values. Same with the ordered pairs. I can only have one coordinate that has 1 as the x value. I'm not going to have that anywhere else. And so these are all examples of functions. They all have only one y output for each x input. We can also extend this to equations and graphs. Now, it can be difficult by looking at equations to tell quickly by looking at it, is it a function or not? And as you learn more functions, you'll be able to identify them a little bit more easily. Some ones that look like weird stuff you might not have seen ever before might be more challenging, although it looks kind of weird and different than what you've seen. And so that might lead you to think that it's not a function, which would be a fair assumption here. When we have the graphs, though, we can take the guesswork right out of it. And we can look at what's called the vertical line test. So functions have the feature, because they can only ever have one y value for each input x value, what that means then is if I were to drag a vertical line across the function, in this case this parabola, given by the equation above, the function only ever touches the vertical line at one point at a time. Right? Notice as I pass it along, it's only ever touching that vertical line in one spot at a time. So this passes the vertical line test, and therefore this is a function. So this one here is a function, and we can say that it passes. So this is because it passes the vertical line test. Vertical line test. And that vertical line test, again, is that the graph of the relation only ever touches the vertical line at one point at a time. Over here, for this other relation, we can see, oh, it looks like it's going to be a function. And then as soon as we get to this spot, now it's touching this vertical line in 3 locations. So this example here fails the vertical line test. So we're going to say fails vertical line test, and therefore not a function. So what we're doing here is a visual test or check to see, are there any x values that produce more than one y value? Well, yes, of course there are. Right here, you can see right here, here, and here. If I input that value of negative 2.5 for x, I'm going to get 3 y values coming out of this relation. So it is not a function. Okay, whereas over here, no matter what value of x I put in, I'm only ever going to get one value of y out. And so that is a function. So again, these are both relations. It just so happens to be that the one on the left is the function. So let's take some of these things we've learned and go back to those first few examples I showed you of relations. And let's figure out which ones of these relations are functions and which ones are not. So looking at this table of values, I'm looking for any repeating x inputs that would lead to different y outputs. I don't see that, so this appears to be a function. On the mapping diagram, I'm looking for more than one arrow coming off of one of our x values, one of our domain values. Well, here you can see we have a problem right there in that 2 arrows are coming from 0, which means when I input my 0, I can get 2 or 8. So this is not a function. Not a function. And again, it's not a problem that we have 2 arrows coming to negative 3. That's allowed, and in fact, parabolas have that feature where you can have the same y value from 2 different x values. So that's not the problem. The problem is this piece right here. That's the issue. If we go over and look at these ordered pairs, we're looking for any repeating x values. And here we can say, oh no, 2 maps to 3, but 2 also maps to 4. That's a problem. So that makes that this is not a function. Notice when I am answering these ones, I can't use the vertical line test because there's no graphical representation here. Let's scroll down to these graphs though and picture the vertical line test again here. Sorry about that. I don't know if you could hear my dog just bark to go outside. Let's look at a vertical line test on this. And in reality, you don't really need to draw a vertical line. You can probably just look at this, but you're welcome to use a straight edge if that helps you, right? And so as we pass this along, it has these series of points, and it never touches this vertical line at more than one spot. So this is definitely a function. So this is a function. And again, it's because it passes that vertical line test. If we then look at the next graph, this line, you've dealt with lines a lot already. It clearly passes the vertical line test as well. All lines will pass the vertical line test except for vertical lines themselves. And so vertical lines are not functions. So this passes the vertical line test, so it's a function. But then when we get to the circle is not going to pass the vertical line test, right? As soon as you get past that first tangential point, it touches at two spots. That means one X input has two Y outputs. And so this one is not a function. So to recap, a function is a special type of mathematical relation that will obey a rule and will have inputs and outputs. But what's unique about it is that each input will only ever have one output as a result. I hope you found this video helpful on defining what a function is. If you have, please consider liking the video and subscribing to the channel. As always, thank you so much for listening and watching.